Good day, sir. Good day, classmates. So today, we will be discussing about a very interesting topic that almost all of us know and familiar. But before we start, let us first introduce ourselves. So we are the reporters for today's lesson. My name is Cornelio Indico Jr. and together with me are my co-reporters, namely Ivan Ray Diadio and Delord Gamusa, which you will meet afterwards. So to begin with, our lesson for today is entitled Robots and Other Motion Control System. I know that most of us are familiar with robots, most especially that we are fond of watching Transformers and Power Rangers. But for today, let us dig deeper and discover the most interesting facts about robots, starting from its origin, how it was coiled, and how it evolved. Aside from that, we will also talk about its types, uses, and motion control system. Exciting, right? So let us start. In the past, the human labor and the aid of domesticated animals both gave the efforts to build the earliest societies. When the machines were invented to perform repetitive tasks like lifting water and grinding grain, and mechanic and complex mechanisms were developed, human labor became less important. As a result, more technological advances developed slightly and widely spread. One of the major technological advancements that led to the creation of the autonomous robots was electronics. In 1954, George Devol invented a digital and programmable robot and called it Unimate. Unimate was later on used to move hot metal objects by General Motors in 1960. So what are robots? So a robot is a programmable mechanical device that can perform tasks and interact with its environment without the aid of human interaction. It is a machine in the form of a human being that performs all function of a human being but lacks sensitivity. What is robotics? So robotics, on the other hand, is the intersection of science, engineering, and technology that produces machines called robots that replicate or substitute for human actions. Pop culture has always been fascinated with robots. Examples include R2D2, The Terminator, and Wall-E. These over-exaggerated humanoid concepts of robots usually seem like a caricature of the real thing. Now that we are able to define what is a robot and robotics, let us now differentiate the two terms. So what is the difference between robots and robotics? So a robot is a programmable machine that can complete a task, while the term robotics describes the field of study focused on developing robots and automation. Before, some people perceive robots as dangerous technological ventures that will someday lead to the demise of the human race, either by outsmarting us to take over the world or by turning us into technology-dependent beings. But to understand more about them, let us go back to its origins and early concepts. So, origins of robots and robotics. The first use of the word robot occurred in a play about mechanical men that are built to work on factory assembly lines that rebel against their human masters. These machines in RUR, or Rossum's Universal Robots, written by Czech playwright Karl Kapek in 1921, got their name from the Czech word slave. The word robotics was also coined by a writer. Russian-born American science fiction writer Isaac Asimov first used the word in 1942 in his short story Runabout. Asimov had a much brighter and more optimistic opinion of the robot's role in human society than did Kapek. He generally characterized the robots in his short stories as helpful servants of man and viewed robots as a better and cleaner race. Early concepts of robots. In 3000 BC, one of the first instances of a mechanical device built to regularly carry out a particular physical task. Egyptian water clocks used human figurines to strike the hour bells. In 400 BC, Archytas of Tarentum, inventor of the pulley and the screw, also invented a wooden pigeon that could fly. Hydraulically operated statues that could speak, gesture, and prophecy were commonly constructed in Hellenic Egypt during the 2nd century BC. In the 1st century AD, Petronius Arbiter made a doll that could move like a human being. Giovanni Torriani created a wooden robot that could fetch the emperor's daily bread from the store in 1557. Robotic inventions reached a relatively peak before the 20th century. In the 1700s, countless ingenious yet impractical automata were created during this time period. The 19th century was also filled with new robotic creations such as talking doll by Edison and the steam-powered robot by Canadians. Although these inventions throughout history may have planted the first seeds of inspiration for the modern robots, the scientific progress made in the 20th century in the field of robotics surpassed previous advancement a thousandfold. Now that we meet Unimate and Shaky, let us now proceed to the most common types of robots. So as robotics manufacturers continue to deliver innovations across capabilities, price, and form factor, robotic solutions are being implemented in an ever-increasing number of industries and applications. Advancements in processing power and AI capabilities mean that we can now use robots to fulfill critical purposes in a plethora of ways. While robotics applications vary greatly, giving directions, stocking shelves, welding metal in dangerous environments, and much more, today's robots can generally be grouped into 6 categories. So the first common type of robot is autonomous mobile robots or AMRs. AMRs move throughout the world and make decisions in near real time as they go. Technologies such as sensors and cameras help them ingest information about their surroundings. Onboard processing equipment helps them analyze it and make an informed decision, whether that's moving to avoid an oncoming worker, picking precisely the right parcel, or selecting an appropriate surface to disinfect. They're mobile solutions that require limited human input to do their job. Automated Guided Vehicles or AGVs. While AMRs traverse environments freely, AGVs rely on trucks or predefined paths and often require operator oversight. These are commonly used to deliver materials and move items in controlled environments such as warehouses and factory floors. Articulated robots. Articulated robots, also known as robotic arms, are meant to emulate the functions of a human arm. Typically, these can feature anywhere from 2 to 10 rotary joints. Each additional joint or axis allows a greater degree of motion, making this ideal for arc welding, material handling, machine tending, and packaging. Fourth is the humanoids. While many mobile humanoid robots may technically fall under the domain of AMRs, the term is used to identify robots that perform human-centric functions and often take human-like forms. They use many of the same technology components as AMRs to sense, plan, and act as they carry out tasks such as providing directions or offering concierge services. 5 is the cobots. Cobots are designed to function alongside or directly with humans. While most other types of robots perform their tasks independently or in strictly isolated work areas, cobots can share spaces with workers to help them accomplish more. They're often used to eliminate manual, dangerous, or strenuous tasks from day-to-day workflows. In some cases, cobots can operate by responding to and learning from human movements. Lastly is the hybrids. The various types of robots are often combined to create hybrid solutions that are capable of more complex tasks. For example, an AMR might be combined with robotic arm to create a robot for handling packages inside of a warehouse. As more functionality is combined into single solutions, compute capabilities are also consolidated. Since we have now an idea about what are the common types of robots, let us now proceed to the fixed versus non-fixed location robots. So robots can also be broadly categorized into two groups, those that move around their environment or the mobile robots and those that do not or stationary robots. So under the category of mobile robots are AMRs, AGVs, humanoids, and hybrids, while in stationary are articulated robots and cobots.
We are now able to differentiate the fixed from non-fixed location robots. So we will proceed to the next topic, which is about the basic components of a robot. The four main components of a robot are the following: body, control system, manipulators, and drivetrain. First is the body or the frame. The body or frame can be of any shape and size. Essentially, the body or frame provides the structure of the robot. Most people are comfortable with human-sized and shaped robots that they have seen in movies, but the majority of actual robots look nothing like humans. Typically, robots are designed more for function than appearance. Next is the control system. The control system of a robot is equivalent to the central nervous system of a human. It coordinates and controls all aspects of the robot. Sensors provide feedback based on the robot's surroundings, which is then sent to the central processing unit or the CPU. The CPU filters this information through the robot's programming and makes decisions based on logic. The same can be done with a variety of inputs or human commands. Next is the manipulators. To fulfill their purposes, many robots are required to interact with their environment and the world around them. Sometimes they are required to move or reorient objects from their environments without direct contact by human operators. Unlike the body, frame, and the control system, manipulators are not integral to a robot. A robot can exist without a manipulator. Lastly, it is the drivetrain. Although some robots are able to perform their tasks from one location, it is often a requirement of robots that they are able to move from location to location. For this task, they require a drivetrain. Drivetrains consist of a power method of mobility. Humanoid-style robots use legs, while most other robots will use some sort of wheeled solution. What are the different types of industrial robots and their applications? Countless manufacturers use industrial robots to automate tasks, enhance worker safety, and increase overall production output while reducing waste and operating costs. With industrial robots becoming more prevalent in manufacturing environments, there has been an increased demand for numerous different types of industrial robots to fit specific applications and industries. At this point, we will explore what type of industrial robots are available on the market, how they work, and what application or industries they are typically used in. First is the Cartesian robots. Cartesian robots, which are also called linear robots or gantry robots, are industrial robots that work on three linear axes that use the Cartesian coordinate system x, y, and z, meaning they move in a straight lines on three axes, up and down, in and out, and side to side. Cartesian robots are a popular choice due to being highly flexible in their configurations, giving users the ability to adjust the robot's speed, precision, stroke length, and size. Cartesian robots are one of the most commonly used robot types for industrial applications and are often used for CNC machines and 3D printing. Next is the SCARA robots. SCARA is an acronym that stands for Selective Compliance Assembly Robot Arm or Selective Compliance Articulated Robot Arm. SCARA robots function on three axes, X, Y, and Z, and have a rotary motion as well. SCARA robots excel in lateral movements and are commonly faster moving and have easier integration than Cartesian robots. Typically, SCARA robots are used for assembly and palletizing as well as biomed application. Next is the articulated robots. Articulated robots, mechanical movement and configuration closely resembles a human arm. The arm is mounted to a base with a twisting joint. The arm itself can feature anywhere from 2 rotary joints up to 10 rotary joints which act as axes, with each additional joint or axis allowing for a greater degree of motion. Most articulated robots utilize 4 or 6 axes. Typical applications for articulated robots are assembly, arc welding, material handling, machine tending, and packaging. Next is the cylindrical robots. Cylindrical robots have a rotary joint at the base and a prismatic joint to connect the links. The robots have a cylindrical shaped work envelope, which is achieved with rotating shaft and an extendable arm that moves in a vertical and sliding motion. Cylindrical robots are often used in tight workspaces for simple assembly, machine tending, or coating applications due to their compact design. Next is the Delta robots. Delta robots or parallel robots possesses 3 arms connected to a single base, which is mounted above the workspace. Delta robots work in a dome shape and can move both delicately and precisely at high speeds due to each joint of the end effector being directly controlled by all three arms. Delta robots are often used for fast pick and place applications in the food, pharmaceutical, and electronic industries. Next is the polar robots. Polar robots or spherical robots have an arm with two rotary joints and one linear joint connected to a base with twisting joint. The axes of the robot work together to form a polar coordinate which allows the robot to have a spherical work envelope. Polar robots are credited as one of the first types of industrial robots to ever be developed. Polar robots are commonly used for die casting, injection molding, welding, and material handling. Next is the collaborative robots. The collaborative robots or cobots are robots that can directly and safely interact with humans in a shared workspace. There are numerous types and brands of collaborative robots on the market. Cobots are typically used for pick and place palletizing, quality inspection, and machine tending. We are now on robot configurations. When selecting an industrial robot, there are many things which need to be considered, such as what is its purpose, how fast does it need to move, what precision of movement does it need, will it be a collaborative robot? All of these considerations and many others determine the type of industrial robot which is best for a job. One of the major factors which determines how industrial robot will move and what limits its workspace its robot configuration. There are six major types of robot configurations: Cartesian, cylindrical, spherical, selective compliance articulated robot arm or the SCARA, and the articulate and the delta or the parallel. Some industrial robots may not be able to scratch the back of their forearm with the same hand, just like most people cannot perform this task. However, through the attention to access and the selection of a configuration, industrial robots can be designed to move their tools quickly, accurately, and repetitively to any point within a three-dimensional workspace.
So these are the robot configuration. First is Cartesian. So has the robot's tool moving in a linear motion along each of the Cartesian coordinates of x, y, and z. This type of configuration can swap out of the box like work envelope. So this is the common uses. Many 3D printers have their print nozzles mounted on Cartesian configuration. So number 2 is cylindrical. Allow its tool to rotate around the central axis. The tool can also move towards and away from central axis, plus up and down the central axis. This configuration creates a work volume in the shape of cylinder. This configuration is typically used for assembly operation, handling of machine tools, and die-cast machine and spot welding. So number 3 is the spherical. Spherical is the tool motion created by the configuration swap out a workspace shaped like a sphere. It has tool rotate around central axis, and the tool can also rotate around the second axis, which is placed at 90-degree angle on the central axis. In addition, the tool can move back and forth along an axis. So with its common uses, they are commonly used for die casting, injection molding, welding, and material handling. So third is selective compliance articulated robot arm or SCARA. Uses pivot points to allow its tool to move in combination of Cartesian and cylindrical motion. This allows the tool to move more quickly and move more easily in certain motion, such as moving in an arc. So SCARA robots are used for assembly and palletizing as well as biomedical application. And fourth is articulated. This type of robot is commonly pictured when referring to an industrial robot. As a minimum, it needs to have at least a shoulder joint, an elbow joint, and a wrist joint. Many examples of this configuration can be both major and minor access. Typical applications for articulated robots are assembly, arc welding, material handling, machine tending, and packaging. For the last is the delta or the parallel. Can move the robot's tool the fastest of all the robot configuration types. It uses parallel linkage to allow its tool to quickly sweep out its workspace. A delta can nimbly and quickly pick and place items in sorting tasks, as well as serve in many other functions. So now let us proceed to motion control for industrial robots. In 1686, Sir Isaac Newton wrote that an object will not change its state of motion unless a force is applied upon it. This is still true today. A robot cannot move without a force. This force comes from a device called an actuator or a device that causes an action. So what are actuators? An actuator is a device which causes something to happen. This could be a robot movement, which is often achieved using motors. An actuator is needed to make the robot wheels turn or the joints of a robot arm to rotate. These are the examples of actuators. Number 1 is a hydraulic. Number 2 is a pneumatics. 3 is electrical motors or stepper motors and servo motors. There are many everyday devices that make things move. Some of these devices are the same thing that make industrial robot move. They may not look the same, but they work on the same principles. So for the first example is the hydraulics. When observing a garbage truck dumping a dumpster, large cylinder can be observed with shaft extending out of them. Lifting the dumpsters, these are hydraulic cylinders. Hydraulic actuators use a pump to pressurize hydraulic fluid. Valves release the fluid through a hydraulic hoses. The pressure in the hoses can cause the shaft of a hydraulic cylinder to move out or move in. The pressure in the hoses can also cause the shaft of a rotation hydraulic actuator to spin. Hydraulic can move and hold very heavy items. A robot with a hydraulic system could be used to move very heavy loads and tools. So the second example is the pneumatics. Other type of actuators that are very similar to hydraulics are called pneumatics. The major difference between these two types of actuators is that pneumatics use air instead of hydraulic fluid. Imagine a balloon. As air pressure blows into the balloon, it extends out. If air is let out of the balloon, it flows out very quickly. This can also happen with pneumatic actuators because activated air can move fast. Pneumatic cylinders are also useful when linear motion is needed. The third example is the electric motor. Washing machines, clothes dryer, vacuum cleaners, and food processor are some examples of household appliances that work because they have an electric motor. Electric motors are actuators that converts electrical energy into rotational mechanical energy that causes a shaft to spin. And next is the stepper motor. Nearly all industrial robots have electric motors for at least some of their actuators. Most of these motors have additionally controls to help the robot move. The special types of electric motors that are found in industrial robots are stepper motors and the servo motors. A stepper motors uses direct current or DC, and the rotation of its shaft is divided into a number of equal steps for better control of the movement of the shaft. And the last example is the servo motor. The servo motor is a sensor or sensors which can be used to control things like position, speed, and acceleration of its shaft. Many toy remote control cars use servo motors to control their steering. The sensors in the motor allow the motor to precisely control how much the toy car's steering linkage are moved.
Types of robotic software for industrial robots. To help you cut through the noise and hone in the right software for you, here are some of the types of robotic software that you might encounter in the market. First is the offline programming. Offline programming software provides a way for you to program your industrial robot without needing to be physically connected to the robot at the time. This means that you don't need to take the robot out of production to program it. It reduces downtime, improves the quality of programming, and allows you to change between product lines quickly, amongst other benefits. The offline programming market is quite fractured, with packages often tied to individual robot brands. Then there is offline programming software that can be used with any robot brand like RoboDK. Robot simulators come in many forms. Some only allow for simple 2D simulation of specific aspects of robotic, while others include 3D simulation with complex physics, engines, and realistic movements. If you wanted to, you could spend a lot of time testing all the many different simulation packages available. But unfortunately, it's difficult to tell from a promotional video how easy a simulator is to use. You have to go out and test it for yourself. third is the middleware. One of the most misunderstood type of software is middleware. The most popular being ROS or the Robot Operating System. Robot middleware provides a framework for running and managing complex robotic systems from a single unified interface. As some people describe it, middleware is the software glue that helps robot builders to avoid reinventing the wheel when they are designing a new robotic system. You probably wouldn't use middleware to control a single robot on a production line. However, if you were to building your own robotic system with multiple components or looking to coordinate multiple robots, you might use middleware to make your life a bit easier during the R&D phase. Mobile robot planning. Mobile robots are programmed in a different way from other robots, which means using a different type of software too. For example, path planners are used to program the route that the robot will take through the environment, while obstacle avoidance algorithms react to changes in the moment. There are a lot of interesting software tools available for mobile robot programming, ranging from warehouse logistics to autonomous vehicles. Real-time path planning. Path planning software is used in many areas of robotics. Basic path planners like our PRM features are simply used to speed up the programming phase for industrial robotics. Real-time path planning is much more complex than basic path planning because it involves continually updating the program to respond to changes in the environment. This allows the robot to be reactive but can also make the robot more unsafe. Software companies who specialize in real-time path planning tend to focus their efforts on a single type of robot like humanoid robotics, mobile robotics, or robotic arms. 6 is the UAV or drone control. A growing type of robotic software is drone control. This refers to any software which is used to program and coordinate unmanned aerial vehicles. There have been a growing number of application areas for drones over the last decades, or so with drones now used in agriculture, inspection, and security. Software for drones tends to focus on particular application areas or aspects of drone control. Examples are data collection, image analysis, and mapping. Lastly is artificial intelligence for robots. Artificial intelligence or AI has been used with robotics for many years, almost as long as robotics have been around. However, there has recently been an increasing number of software solutions specifically for using AI with robots in particular application areas. As with the other types of robot software, AI tends to be focused on specific aspects of these applications, such as analyzing images collected in agricultural settings, filtering operational data in manufacturing environments, or coordinating swarms of mobile robots in logistics.
And now, let us proceed to the three basic robot programming methods. So number one is the teach method. This method involves using a teach pendant to guide the robot through a series of points and having store them in memory. The process of guiding and recording these points or coordinates in space is called teaching in robotics. Here are some of reasons why this method is preferred to others. Number one is precision. The operator can input very precise points or coordinates into the teaching pendant, thus making it easier to ensure that the robot arms are worked as expected. The second is safety. As a result of the precision, it's easier to ensure that the robot arm and the moving part will stay within predefined space for safety purposes. This is especially important for robots that have safety stop or collision detection as feature. The third is the intuitiveness. Modern tablet-operated teaching systems are quite intuitive that robotics engineer may not be required to program or program the industrial robots. The second is the hand guiding or leading through programming. Hand hiding or lead through programming involves physically moving the robot arm over a series of points and axes to teach it how to perform a desired function. For instance, an operator can guide a robot on how to reach for a tool on a workstation and use it to do some operation. After the instruction have been recorded by the robot's memory, it will continue following the same path on its own. These are the some of the advantages of lead-through or hand guiding. First is the intuitiveness, second is the safety, third is collaboration, and fourth is great for complex tasks or movements. And the last example is the offline robot programming. As the name suggests, this robot programming method involves writing instruction in a separate system and using virtual models of an industrial robot for testing. After the instructions have been written and tested, they are uploaded to the robot's memory. This method is preferred when a lot of instructions need to be written and tested before being deployed in a real life. And these are the some examples of the advantages of offline programming. Number one is allows for more complexity. Second one is can lead to more efficient robot operation. Third is their support precision. And last is the guarantees safety.
Now, we will discuss the four types of robots control system. First is the point-to-point control robot or the PTP. The PTP robot is capable of moving from one point to another point. The locations are recorded in the control memory. PTP robots do not control the path to get from one point to the next point. Common applications include component insertion, spot welding, hole drilling, machine loading and unloading, and assembly operations. Next is the Continuous Path Control Robot or CP. The CP robot is capable of performing movements along the controlled path. With CP from one control, the robot can stop at any specified point along the controlled path. All the points along the robot path must be stored explicitly in the robot's control memory. Application straight line motion is the simplest example for this type of robot. Typical applications include spray painting, finishing, gluing, and arc welding operations. Next is the controlled path robot. In controlled path robots, the control equipment can generate paths of different geometry such as straight lines, circles, and interpolated curves with a high degree of accuracy. Only the start and finish points in the path definition function must be stored in the robot's control memory. It is important to mention that all controlled path robots have a servo capability to correct their path. Last is the stop-to-stop. It is open-loop system. Position and velocity unknown to controller. On and off commands stored as valve states. And trouble set by mechanical. How robots are used across industries. Businesses and government agencies use robotics. How robots are used across industries. Businesses and government agencies use robotics in a variety of ways. All five of them common robot types are deployed to enhance outcomes and reduce the burden on employees so they can focus in the most valuable and most critical tasks. Robots used for industrial. The manufacturing industry has long been at the forefront of using various types of robots to achieve business results. AMRs, AGVs, articulated robots, and cobots are all deployed on factory floors and in warehouse to help expedite processes, drive efficiency, and promote safety, often in conjunction with programmable logic controllers. They're used across a variety of applications, including welding, assembly, materials transportation, and warehouse security. Next is robots for farming and agriculture. AMRs are helping farmers harvest their crops more quickly and efficiently, and they're using impressive intelligence capabilities to do it. Agricultural robots can assist ripeness, move any branches or leaves out of the way, and pick the crop precisely and delicately to avoid causing any harm to the product. So, robots for healthcare. Various types of robots are used in the healthcare industry to enhance the patient experience. AMRs are used to deliver medication, disinfect surfaces, or provide mobile telepresence functionality. Cobots are also used to assist medical professionals during rehabilitation or to help nurses better serve their patients. For logistics, robots help logistics and shipping companies to deliver goods quickly and efficiently. They use AMRs and AGVs as warehouse robots that help them process items, expedite operation, and increase accuracy. They also employ AMRs to take shipments the last mile and ensure safe delivery to customers. Robots for retail and hospitality. Robotics can be used to enhance the customer or guest experience in a variety of ways. Retail and hospitality companies are using robotics to automate inventory processes, provide concierge or wayfinding services, clean various environments, and assist customers with their luggage or valet parking. Last is for smart cities. Robotics help create smarter and safer cities. Humanoid robots offer wayfinding and information services. AMRs are used to deliver goods and conduct routine security patrols. Robotics also help expedite building construction, conduct site surveys, and collect building modeling information. So that's all for our discussion about robots. We hope that you learned something from our report. Thank you for listening and watching. Have a great day.